Assalamu alaikum and good evening, everyone. Today we are going to start October number 2023, paper 2-2. Let's start with question number 1. The elements silicon, phosphorus, and sulfur are in the period 3 of periodic table. Describe the variation in the atomic radius of silicons to sulfur. Okay, so if you recall, they are in period 3. So in period 3, here we got sodium, then we have magnesium, then we have aluminium. After aluminium, we have silicon, phosphorus, sulfur, chlorine. Let me write it like this: aluminium, silicon, phosphorus, sulfur, chlorine, and then there is a argon. Okay, so they are talking about these three. So if you recall, or if you look in the periodic table, you will find its atomic number is 14. Wrong, Anshara. Its atomic number is 15 and its atomic number is 16. So what is happening? That the nuclear charge is increasing, right? What is happening? Nuclear charge is increasing and electrons in same shell is increasing. If the electrons in same shell is increasing, it means, yes, very good, Hassan, it decreases. It means that the forces of attraction is going to be stronger between the nucleus and the electrons, and as a result, the electrons come closer, so the atomic radius decreases. Very good, Umar and Hassan. So it decreases from silicon to sulfur. Now, the melting point of silicon is 1410 degrees Celsius and the melting point of sulfur is 113 degrees Celsius. Okay, so if you see, silicon is a non-metal, right? And sulfur is also a non-metal. But the difference is, very good, Umar. The difference is its melting point is high, although it's a non-metal, and its melting point is low as it's a non-metal. So we have to explain this, right? So silicon is giant covalent and has, yes, very good, Bunny, strong covalent bonds between all atoms. Sulfur is simple molecular, and how we are concluding this by observing their boiling point, melting points, is simple molecular and has intermolecular forces or van der Waals forces between its molecules. So this covered 2 marks only. And for the third part, we are going to write more energy is needed to break covalent bonds in silicon than intermolecular forces in sulfur. Is this understandable to all of you? Now, table 1.1 shows some properties of the element silicon to sulfur. The first ionization energy of phosphorus is not shown. Okay. So if you recall their groups, it's group 6, sorry, it's group 14 or 4, it's group 15 or 5, and it's group 16 or 6. Complete table 1.1 to show the total number of S and P electrons in an atom of silicon and phosphorus. Silicon, phosphorus, and sulfur. Okay. So as we have discussed, its atomic number is 14, it's 15, and it's 16. So if you will write their electronic configuration, so it is going to be 1s2, 2s2, 2p6, 3s2, 3p2, right? One s2, 2s2, 2p6, 3s2, 3p2 for 14 electrons. Now, for phosphorus, it is 1s2, 2s2, 2p6, 3s2, 3p3. For sulfur, 1s2, 2s2. Intermolecular forces, Umar, IMF, intermolecular forces. 2p6, 3s2, 3p4. Now, yes, very good, Umar. Now, if you see the S subshell, so S, and S, how many electrons we have in S subshell? For all three of them, there are 6 electrons in S subshells of each atom. Is this clear? Now, if we go for the P electrons in P, so in silicon in P, there are 8 electrons. In phosphorus, there are 6 plus 3, 9 electrons. And in sulfur, there are 6 plus 4, 10 electrons. Is this understandable to all of you? Okay. Now, construct an equation to represent the first ionization energy of silicon. So the first ionization energy of silicon, that silicon gaseous atom forming silicon 1 plus gaseous ion plus electron. Is this clear? Okay. Now, third, 3 possible values for first ionization energy of phosphorus. So let me recall. One minute, please. We have, if you see the groups, group 14, group 15, group 16. Here we have silicon, here we have phosphorus, here we have a sulfur. If you recall, it's 3p2, it's 3p3, and it's 3p4, the outermost. And if you recall, the ionization energies, it would be like this. For example, if this one is of silicon, then this would is of phosphorus if I make the ionization energy over here. And then this one is for sulfur. So sulfur's ionization energy would be like this. So if we look at the phosphorus, the phosphorus ionization energy is greater than both silicon and sulfur. So if you look, silicon's ionization energy is 786 and it's 1000. So it must be greater than 1000. So we are asking to circle the correct value and sorry. So the correct value would be 1060 kilojoule per mole. Is this understandable? No, it will be higher than sulfur. It's not lower than sulfur. Omar, I have just explained you that it's higher than sulfur. Okay. Just give me a minute, please. Okay. So explain your choice, including a comparison of your chosen value to those of silicon and sulfur. So the thing is that in silicon, there are two unpaired electron in P. In phosphorus, in phosphorus, yes, there are three unpaired electrons, and in sulfur, there is a pair and two unpaired electrons, right? So we will start if we compare phosphorus and silicon, that phosphorus has greater nuclear attraction than silicon because the nuclear charge of phosphorus is greater than silicon, right? Because silicon has a 14 protons and the phosphorus has a 15 protons. Now, so that is the comparison. When we are going to compare it with the sulfur, phosphorus and sulfur, so there is a pair over here due to which, although it has a greater nuclear charge, but the pair of electron repel each other and as a result they got at a distance. So in sulfur, one of the 3p orbital has pair of electron which causes spin pair repulsion. Hence, the nuclear attraction in sulfur gets weaker than phosphorus. Is this understandable to all of you? Okay. If any one of you has any confusion, you can ask. SiCl4 and PCl5 each react with water forming misty fumes. Identify the chemical responsible for the misty fumes. So the misty fumes always are hydrogen chloride because they has a chloride in them. So hydrogen chloride is the one which forms misty fume. For example, if instead of chloride here, got a bromides, right? And then they ask you for the misty fume. So then in this case here, it must be HBr. Now, predict the shape of SCl2 molecule. So in SCl2, sulfur is bonded to chlorine, right? Sulfur is the central atom. So sulfur is in group 6. So if it's in group 6, you see there are two bond pairs. So it means two electrons are, yes, very good, Hassan. Two electrons are involved in bonds. So two bond pair, and there must be two lone pairs as well because there are 6 electrons. So out of 6, two make bond, two involved in bonds, and 4 are left. So 4 lone pair. Oh, sorry, 4 are left, which means 2 lone pair. So whenever this is the case, the shape is bent, or you can say V shape, or you can say non-linear, or you can use the term angular. All these can be accepted. So it's a bent shape, or it's a V shape, or it's a non-linear shape, or it's an angular shape. Is this clear to all of you? Okay. Now, question number 2. Nitrogen and nitrogen dioxide reacts at 25 degrees Celsius to give N2O3 as shown in equation. The reaction is reversible and reaches equilibrium in a closed system. Figure 2.1 shows how the rate of forward reaction changes with the time. Initially, the rate of reverse reaction is 0. Complete figure 2.1. Sketch how the rate of reverse reaction changes with the time. Okay. Okay. So we know that they have mentioned the equilibrium is reaches. So at equilibrium, there is a same rate or same rate of forward and the backward reaction. So it means as they have mentioned you that the rate of reaction is, initially 0. So, and at equilibrium, it becomes, it would be like this. We have to make the horizontal line at the same level because they have mentioned that it's equilibrium, and at equilibrium we know that the rate becomes equal for the forward reaction and for the backward reaction, right? Now, B part. State the position of equilibrium changes if at all when the reaction takes place at 100 degrees Celsius. Explain your answer. Assume the pressure remains constant. So we know that what happens, they have, what they did, they increased the temperature. So remember, increase in temperature, when the increase in temperature occur, equilibrium shifts to endothermic side to reduce the excess heat. So if you look at this reaction, it's minus 72. So it means the forward reaction is exo, sorry, and the backward reaction is endo. So if the backward reaction is endo, it means that if we increase the temperature, equilibrium shifts towards the back or towards the left. Okay. So equilibrium, the backward, it favors the backward reaction because because the forward reaction is exothermic, or equilibrium shifts to reduce or oppose the change in the uh, increased temperature. Yes, Fatma, pressure would, if we increase the pressure, equilibrium shifts towards the side which contains lesser moles of gases. So we have to see whether reactant side has a lesser moles of a gases or a product side has a lesser moles of gases. Okay. So here, equilibrium position shifts to the left or backward as forward reaction is exothermic, or you can write backward reaction is endothermic. Hence, to reduce the increased temperature or to oppose the increased temperature. That's what Lee Teichler principle explained to us, that equilibrium always shift in a direction to oppose whatever the change that occurs or that applied. Now, table 2.1 shows the composition of an equilibrium mixture of nitrogen monoxide gas, nitrogen dioxide gas, and dinitrogen tetroxide gas. Okay, the number of moles of at equilibrium. Okay, they have given you the number of moles at equilibrium, and here we got the equation. Okay, calculate the Kp, equilibrium constant with respect to partial pressures. Okay, so let me write the equation. NO2 is reacting with NO and forming N2O3. So if you recall the Kp expression is equals to partial pressure of N2O3 over partial pressure of NO2 times partial pressure of NO. Is this clear? Now, did they mention the total pressure? Okay, yeah, here we have a total pressure, right? They have mentioned the total pressure. Okay, so recall, if you need to recall the formula of partial pressure of N2O3 can be calculated by multiplying the mole fraction of N2O3 times total pressure. So for the mole fraction of N2O3, mole fraction of moles of N2O3 divided by total moles. So can anyone calculate the total moles over here? That 0.605 plus 0.605 plus 0.390. Can anyone calculate it? Yes, they have mentioned the pressure over here that it is constant for this thing when you are increasing the temperature. So we have explained that when the temperature is increased, how the equilibrium shifts. Okay. Yes, can anyone calculate it and tell me the answer, please? It's 1, 0. Is it 1.66, 1.600 on adding them? Can anyone confirm me, please? Okay, so the moles of N2O3 divided by total moles times total pressure, which is 101, give me the partial pressure of N2O3. In the same way, if I have to find the partial pressure of NO2, it is equals to mole fraction of NO2 times total pressure. So the mole fraction of NO2 would be 0.605 over 1.6 times 101. In the same way, the partial pressure of N2O3 is equals, sorry, not N2O3, moles fraction of NO. Partial pressure of NO is equals to mole fraction of NO times total pressure. So the mole fraction of NO is also equals to 0.605 over 1.6 times 101. Is this working is understandable to all of you? Can anyone calculate the values and tell me the answer? See, for Kp expression, you need to calculate the partial pressure, and partial pressure is equals to mole fraction of that gas times total pressure. Mole fraction can be calculated by keeping the moles of that specific gas over total moles. So we identified, we calculated the total moles, and then we put it in the expression, and then we multiply it with the total pressure, we will get the partial pressure of N2O3. Same thing we did with the partial, to find the partial pressure of NO2, we keep the moles of NO2 and divide it with the total moles to that becomes mole fraction, and when divided by total pressure, it will become the partial pressure of NO2. Same thing we did with NO. Is this clear? Okay, thank you, Fatma. It's 38.19. Next one. 38.19 is for which gas? Fatma, is it for N2O3 or is it for NO2? Okay, so NO and NO2 both have going to have a same partial pressure because their values are same. Now, can anyone calculate the partial pressure for N2O3? It's 24.62. Okay, thank you. So 24.62 divided by 38.19 whole square, because you have 2 times 38.19 times 38.19. Now calculate the value of Kp, please. They are asking for the unit. If you see the total pressure as a unit of kilopascal, it means partial pressure is also going to have a unit of kilopascal. So kilopascal over kilopascal square. So we are going to left with kilopascal inverse. Now, can anyone calculate the answer for Kp value and tell me, please? Thank you, Fatma. Thank you, Inshra. It's okay, but you guys are telling me in 2 significant figures, and Umar, you are telling me in 3 significant figures, but do tell me that is it 0.0168 after it? Do we have some other digit, Umar? You have to keep the answer in 3 significant figures, everyone, okay? Yes, Umar, after 8, do we have some other? So see, that is the mistake if you do it, because when we keep the 3 significant figures, it is going to be round off to 0.169. So that will be the correct answer. Otherwise, if you will write 0.017 or you will write 0.0168, you will not get the mark for the result. Okay. Now, D part. Identify one natural process and one man-made process that causes the formation of atmospheric nitrogen monoxide and nitrogen dioxide. Okay, so natural process is lightning, and the man-made process is the internal combustion engine that causes the formation combustion of nitrogen gas, and as a result it reacts with the oxygen in the from the atmosphere to form nitrogen oxides. Is this clear to all of you? Yeah, but do mention combustion in car engine. Okay. Now E part. NO2 is a brown gas that can be used to form nitric acid. NO2 is a free radical, defined free radical. So do remember, whenever they ask you a free radical, so it is a species containing yes, very good, Umar, very good, Banin. The one which has an unpaired electron, not non-bonding electron. Unpaired electron. Okay. NO2 has a catalytic role in the oxidation of atmospheric sulfur dioxide. Write equation to show the catalytic role of NO2 in this oxidation. So, if you remember that NO2 reacts with sulfur dioxide, as a result, it loses its oxygen to sulfur dioxide, turns into NO, and sulfur dioxide turns into sulfur trioxide. And when the sulfur so the sulfur trioxide is formed, and the NO formed over here quickly react with the oxygen in the atmosphere and restored itself as a NO2, which shows it's as a acting as a catalyst. Okay. State one, environmental consequences of oxidation of atmospheric sulfur dioxide, which in turns into sulfur trioxide. When it dissolves in water, it forms sulfuric acid. So it means that it causes acid rain. Yes, very good. Anshara, Banin, Umar. Now, a student titrates nitric acid with a base to form solution containing aqueous magnesium nitrate. So see, nitrate comes from nitric acid. Identify a base. So magnesium is of comes from base. So the base are metal hydroxides usually, or metal oxides usually. But for group 1 and group 2, these are usually hydroxides. So it's magnesium hydroxide. Is this clear? Umar Sabir, it's not magnesium, the formula is wrong. And who is saying sodium hydroxide? So you are making magnesium nitrate, right? You are getting magnesium. So the base should be magnesium, containing a magnesium in it. Yeah. And if you have to write the formula, so it would be this thing, MgOH twice. And if you just write MgOH, you will not get any mark. Okay. The student evaporates the water to obtain magnesium nitrate solid. When this solid is heated, it decomposes. Write an equation for the decomposition of magnesium nitrate. So it's a group 2 nitrate. So remember group 2 nitrate, there is a general equation for the decomposition, which I have discussed. When you heat it, it forms magnesium metal oxide. 2 moles of nitrogen dioxide has been formed and half mole of oxygen is formed. So these two are gases, and this is a solid, and this is a solid. And do remember that due to this gas, the observation would be brown fumes. Okay. So in this equation, they have mentioned magnesium nitrate. So I replace M with the Mg to show you the equation. Magnesium nitrate solid forms magnesium oxide solid. 2 moles of nitrogen dioxide gas and half mole of oxygen gas. Show how thermal stability of group 2 nitrates changes down the group. So it's the trend that you need to remember, the trend that it increases down the group. The solubility of group 2 sulfates decreases down the group. The solubility of group 2 hydroxides increases down the group. The thermal stability of group 2 nitrates and group 2 carbonates both increases down the group. So you need to remember this. Is this clear to all of you? Okay, so we are done with 2 questions, and this paper has a 4 questions. So we are left with third and fourth question, and these two we are going to do in our next class. Okay, so see you everyone in the next class. Take care. Allah Hafiz.